Hello everyone. In this video we will discuss the D flip-flop, also known as the delay flip-flop or the data flip-flop. We have seen in the previous class that a clocked RS flip-flop requires two input signals to drive the flip-flop, which is a disadvantage with many digital circuits. We have also seen that when both the inputs signals becomes high, it gives an undesirable condition. So these drawbacks of clocked RS flip-flop are overcome in D flip-flop. A D flip-flop is simply an RS flip-flop with an inverter in the R input. By adding this inverter from the S input to the R input, the number of the inputs to the flip-flop reduces from 2 to 1. That is why sometimes this type of flip-flop is also called a gated D latch. The logic diagram, circuit diagram and the symbol of D flip-flop has been shown in the figure 1, 2 and 3 respectively. From the diagram we see that only one single input D is required to drive the flip-flop. That is, only a single data bit D is required to drive the flip-flop. When the clock signal is at low level, then the data bit D is prevented to reach at the output Q until the clock signal becomes high during the next clock pulse. Now we will see how the D flip-flop works. When the data bit Dn is high, then the output Qn plus 1 also gets at high level. And when the data bit Dn is low, then the output Qn plus 1 gets at low level. मतलब जब D का वैल्यू जब हाई होगा 1 होगा तो यहाँ पर भी हमको 1 मिलेगा, जब D का वैल्यू 0 होगा तो फिर यहाँ पर भी हमको 0 मिलेगा. And Q remains in the same state until the next pulse of the clock arrives at its input. और Q का फिर वैल्यू इसी स्टेट में रहेगा जब तक कि नेक्स्ट क्लॉक पल्स उसके इनपुट पर नहीं आता है. The truth table for D type of flip-flop has been shown in this figure. तो यहाँ से हम लोग देखते हैं जब Dn का वैल्यू 0 होगा तो आउटपुट Qn प्लस 1 भी 0 मिलेगा, जब Dn का वैल्यू 1 रहेगा तो आउटपुट Qn प्लस 1 भी 1 मिलेगा. तो इस तरह से हम देख रहे हैं कि सिर्फ D टाइप ऑफ फ्लिप-फ्लॉप सिर्फ 1 बिट ऑफ इंफॉर्मेशन को स्टोर करता है. इट कैन स्टोर आइदर 0 और इट कैन स्टोर आइदर 1. Since the transfer of the data from the input to the output is delayed, so this flip-flop is also named as the delay or the D type of flip-flop. And this D type of flip-flop is either used as a digital device or as a latch to store 1 bit of binary information. That is, it can store either 0 or it can store either 1. Now we will discuss the edge triggered D flip-flop. In a D type of flip-flop, sometimes presence of some external signals like noise is found on the input side along with the relevant input data. कभी कभी क्या होता है कि इनपुट डाटा के साथ कुछ एक्सटर्नल सिग्नल्स भी जैसे कि नॉइज़ भी प्रेजेंट होता है. So these external signals on the input side of the flip-flop may lead to wrong output if they appear when the clock signal is high. तो अगर external signals like noise अगर present है तो ये अगर flip-flop में जाएगा इनपुट के साथ जब clock signal high होता है तो इसके कारण हो सकता है कि जो आउटपुट है वो हमको सही नहीं मिले. तो ये जो प्रॉब्लम है इसको ओवरकम कर सकते हैं हम लोग. दैट इज़ दिस प्रॉब्लम कैन बी ओवरकम अप टू सम एक्सटेंट इफ़ द टाइम ड्यूरेशन ऑफ द पल्स इज़ रिड्यूस्ड. इस प्रॉब्लम को ओवरकम करने के लिए हम लोग इसका क्या करते हैं, इसका टाइम, इसका जो पल्स है उसको अगर हम लोग रिड्यूस कर दें ड्यूरेशन ऑफ द पल्स को, तो ये जो प्रॉब्लम है रॉन्ग आउटपुट का इसको बहुत हद तक हम लोग इसको एलिमिनेट कर सकते हैं। और इसी प्रॉब्लम को ओवरकम करने के लिए द क्लॉक पल्स इज सप्लाइड टू अ ट्रिगर सर्किट विच प्रोड्यूसेस अ शॉर्ट ड्यूरेशन पल्स टू मेक द फ्लिप फ्लॉप इनेबल। इसलिए हम लोग इसको एक ट्रिगर सर्किट में क्लॉक पल्स को देते हैं जो शॉर्ट ड्यूरेशन ऑफ पल्स हमको देगा, जिससे कि फ्लिप फ्लॉप फिर वर्क करेगा। नाउ डिपेंडिंग अपॉन द trigger circuit, there are two types of edge triggered D flip flop. If the trigger circuit responds when the clock pulse goes from low level to high level, then it is known as positive edge triggering or leading edge triggering. And if the trigger circuit responds when the clock pulse goes from high level to low level, then this type of triggering is known as negative edge triggering or trailing edge triggering. The symbols for the edge triggered D flip flops has been shown in the figure A and 5A and 5B. And the truth table for positive edge triggered D flip flop has been shown in this table. So let us see the symbols for both types of triggering. These are the edge triggered D flip flop. This is positive or leading edge triggered D flip flop, and this is the symbol for negative or trailing edge triggered D flip flop. So in positive or leading edge triggered D flip flop, we find that this is the data input D, this is the output Q, and this is the output Q bar, and this is the clock. So this flip flop will respond when the value of the clock pulse goes from low level to high level. That is, it will respond at this edge, that is when the value of the clock pulse goes from 0 to high, because this flip flop responds at this positive edge. That is why this is known as positive or leading edge triggered D flip flop. Similarly, this is the symbol for negative or trailing edge triggered D flip flop. We find from this figure that this is the data input, this is the clock, this is the output Q, and this is the output Q bar. This flip flop will respond when the value of the clock pulse goes from 1 to 0. That is, it responds at this negative edge when the value of the pulse goes from 1 to 0. That is why this type of flip flop is called negative or trailing edge triggered D flip flop. This shows the truth table for positive edge triggered D flip flop. Since this is the positive edge triggered D flip flop, so the value of the clock has been denoted by an upward arrow. That is, the value of the clock is going from 0 to 1. So it has been shown by upward arrow. Upward arrow denotes that this is positive edge triggered D flip flop. From this truth table, we find that when the value of D, that is data, is 1, then the value of the output is also 1. Similarly, if the value of data D is 0, then the value of the output is also 0. Similarly, we find that if Q is 1, then its complement is 0. If Q is 0, its complement is 1. So we find that when the value of D is 1, the output is 1, and so the flip flop will get set. That is, it will store a 1 as the binary information. Similarly, when the value of D is 0, the value of the output will also be 0, and the flip flop will get reset. That is, it will store a 0 as the binary information. So here we find that the same data is transferred to the output. That is why this flip flop is also called the data flip flop. And because there is a delay in transferring the data from the input to the output, so this flip flop is also called a delay flip flop. So we can call it a D flip flop, delay flip flop, or data flip flop. This is how a edge triggered D flip flop works. Hope this topic is clear to all of you.